Hello, everyone. We have a full house. Welcome to Demystifying Sharding. Clearly, based on the attendance here, this is something we're all pretty interested in. Just a couple things before I actually start the talk. We do have a very full room, so I'll do my best to field questions after the talk. If we do run out of time, our speaker will be available outside of the room to sort of answer questions outside there. We do have a tight schedule, so just out of respect for speakers and also your fellow attendees, let's make sure that we can file out properly after. Cool. So our speaker today is on the Sharding team in NYC. She's a UT alum and works on our horizontal scaling solutions. So help me in introducing Sonika Fancy.
All right, hey everyone. Let's start with a couple questions. By show of hands, who finds sharding intimidating? There we go. Quite a bit of the room here. Better question yet, who could even tell me what sharding is? And no, it's not what your 7-year-old son thinks it is. Yeah, a pretty opposite-looking room here. And I asked this question because just as of 6 months ago, I couldn't have answered it myself. Yet, here I am giving a talk demystifying it all. Hey everyone, my name is Sonika Fancy, and I'm an engineer on the Sharding team here in New York. Just a year ago, I graduated from University of Texas at Austin. Do I have any fellow Longhorns in the room? Yeah, hook 'em, there we go. And past the summer, I joined MongoDB as a new grad. One of the flagship parts of the new graduate program here is a rotational scheme, where we get to try 3 different teams for 6 weeks each across departments and get a chance to immerse ourselves in the team and see what will be a good home for us for the foreseeable future. My second rotation was on sharding. And truth be told, between you and I didn't know if I would return because I had never heard of sharding. And yet, it's kind of like they say in rom-coms, when you know, it just clicks. And just maybe a week in, I knew sharding was where I was going to return. And it boiled down to the fact that distributed databases, making them work is hard. Yet, here's a team that loves taking on challenges, loves solving problems collaboratively, and truly, in my opinion, comes up with some of the most cutting-edge parts of MongoDB's technology. So I'm here to share with you both that excitement and hope that you leave feeling a little more equipped and prepared to take sharding back to your applications and your teams, because it'll make sense. We're going to accomplish this through 3 sections. First, go through the intuition behind sharding, discuss the architecture of a sharded cluster here at MongoDB, and then go through what will be your first step in sharding your cluster, which is selecting a shard key. All right, so I've actually brought a time machine with me, and we're going to take a trip back to the 70s, put servers aside, and go back to when we used file cabinets. So can I have a volunteer from the room? Raise a hand. Hey, what's your name? Tristan. Hey, Tristan. Congratulations. You have launched a business today. Woo, round of applause for Tristan. Your business is a retail business, and you identified pretty early on that you need some sort of infrastructure to store your information. So you took a trip to Office Depot and said, hey, can I have a file cabinet? They said, sure. So how many drawers do you need, Tristan? And you said 1 will do. I've just started my business. A file cabinet with 1 drawer will be plenty. So you take this back home, you get hard at work. A month in, you're opening your file cabinet, and it's stuck. You go back to Office Depot and you say, hey, I filled up my file cabinet. My business has been doing so well. I'm ready to upgrade. I'm ready to scale. Can I have one now with the capacity of 2 drawers? They said, sure, Tristan, we have tons of those. So he exchanges his 1-drawer file cabinet for a 2-drawer file cabinet. And as time keeps going, he continues excelling. He's on to a 3-drawer file cabinet, a 4-drawer file cabinet, and Actually, has anyone heard of Walmart? Yeah? Well, that's Tristan's business. So as we know from the future, it really exploded. And yeah, a round of applause for that. And before he knew it, he was at Office Depot asking for a 16-drawer file cabinet. I don't know about you, but I've never seen one of those. And so they said, OK, I guess we can make you one, but it's going to be hard. It's going to take time. We need to completely redesign this infrastructure for a file cabinet. It's going to be really expensive because it'll have to be custom built for you. So I guess if you have $1 gajillion to dish out, sure. But point was made for Tristan. It was super expensive, not a commitment he wanted to make. Moreover, he thought about it, and it didn't even fit in his house. He'd reached the ceiling. He would have to upgrade all the infrastructure surrounding his cabinet. Searching through this cabinet would get really, really hard. He'd have to get a ladder. He might fall off the ladder. But all in all, this was a complicated situation, right? Having this really tall file cabinet. So Office Depot said, OK, let us make you a suggestion. What's important to you is that you have this capacity of 16 drawers. So instead of one really tall file cabinet, how about we give you 4 4-drawer file cabinets? And that is exactly the intuition behind sharding. Here, you still have this capacity of 16 drawers, but they're in 4 individually made cabinets of standard sizes, right? These are run-of-the-mill 4-drawer file cabinets. And in fact, as Tristan continues to scale, he can just keep adding cabinets onto the side. And so long as that's the case, he can scale infinitesimally, and he's not going to break his bank trying to create all of this new technology in order to store his data. So as you might have guessed, file cabinets translates directly to servers, right? We're back in 2022. So sharding is your solution at scale. Once you've started to hit some sort of capacities of what your servers can support, sharding becomes your solution. But what are the types of capacities that you can hit with the server? Well, there's 3. First is storage, right? You might be hitting those terabyte ROM limits. Second is CPU and RAM. So if you're running a lot of processes, you need a lot of processing power, you might be hitting that type of capacity on your server. And the third is throughput. So this is if you're really testing network band limits by sending all of your queries to a singular shard, or a singular server rather, or literally the IOPS reads and writes on the server itself. And when you shard, you multiply the capacity and the capability, the magnitude of all of these capacities by the number of shards you've introduced. So a 4-sharded cluster will quadruple all of these capacities. So now that we understand the motivation behind sharding, why it makes sense, right? Let's go into the architecture of a sharded cluster. So how do we at MongoDB implement sharding? One thing you might have noticed, going back to the file cabinet analogy, is now we have the data living in 4 distinct physical spaces. So how do we tie it all together such that you, as the database user, still feel like you're communicating with one database? To visualize this, it helps to start off with the base case, which is a replica set. So initially, you're running a cluster, and your application is communicating directly with a replica set. As a reminder, that means you have 1 primary node that's the leader of the set, and you have 2 secondary nodes that act as backup copies. Now, when you shard, that replica set becomes your first shard, and your application, rather than communicating directly with that shard, goes through another layer that is a series of processes called routers, or MongoS. And what these routers do is they route queries from the application to the set of shards. So here we have, say, 3 shards, each a replica set in and of themselves, and the application can communicate directly solely with the MongoS. So the router itself is a multi-threaded process so that it doesn't act as a bottleneck for your queries. But additionally, you can have any n number of routers, which means that, again, you can parallelize your querying significantly. And finally, we have a third server, or an additional server, third process called the config server that holds metadata describing your sharded cluster. And specifically, it has something called the routing table, which is the single source. The config server's version of the routing table is a single source of truth describing where documents live in the shards. Let's dig a little deeper into the routing table. The routing table is a key to value mapping between documents and shard connection strings. As I mentioned, the config server has the single source of truth of that. So it has the most updated version of the routing table, whereas MongoS's or the routers have cached copies of this routing table so that they don't have to make this trip to the config server every time that they receive a query. However, if we use the entire document as your key to the shard connection, it would be really inefficient, right? Documents can be ginormous. So instead, we use a shard key. So we ask you to specify one field or a couple of fields hyphenated together to be identifying factors for your documents so that the routing table can map those documents from that key to the shard connection string. An additional process that runs on the config server is the balancer. And what the balancer does is it partitions your data across shards. So you only have to specify what you want your shard key to be, and the balancer takes care of distributing your data across the shards in a way that is even. So here, just for the sake of example, we specified _ID as the shard key, and the balancer partitioned the data across the 4 shards. And as a reminder, you have a primary node in your replica set and 2 secondaries. And this is a diagram that we'll reference a lot going forward, so keep it in mind. I thought it would be helpful to go through the life cycle of a couple of queries to really understand how the sharded cluster works. Our first command is going to be an update1 command. Here, we have specified that we want to find the document with the _ID value of 90, which, as you remember, we had specified to be our shard key earlier. And we want to set the test3 value to 98. So this student's been killing it, doing better than I did in school. So remember, we said that _ID value was what we partitioned by, and that 90 would have existed on that first shard, right, by that value. So the driver or your application sends the command to the team of routers, and one of the routers picks it up. This router then checks its cached copy. I'll show you here. It checks its cached copy of the routing table and identifies that that _ID value of 90 should exist on shard 1. So it forwards your query to shard 1, and shard 1 is aware of which range of shard key values it's responsible for. So once it sees that, yes, I do have 90, it executes the command, executes the update, and returns success to the router, which returns that value then to your application. Now consider, what if data was rebalanced? So say over time you inserted a lot of documents that were very heavy on a low _ID value, right? So to maintain even distribution of data across the shards, the balancer auto-rebalanced all of the data, and now 90 should exist on this third shard. The router might still have a cached copy of the routing table that indicates that that document would be on shard 1. So it sends this query to shard 1. However, shard 1 will recognize that I am not responsible for a shard key of value 90, and return that you probably have a stale copy of the routing table. Now, the router will go make a round trip to the config server to update its copy of the routing table, otherwise known as a lazy update, and then do what we did earlier, as it sends its query directly to shard 3. Everything is successful after that, and we receive success on the application side. So from the application's perspective, nothing was different. It still sent its query, received an answer. Now, what if the shard key is not even specified in the query? So suggest you're doing a find where the age is 10, right? Our shard key, again, reminder, was the _ID value. What happens here? So the router realizes that it is unaware of where your data exists, so it sends the query to all the shards, right? And then it waits to gather the responses from all of the shards before returning to the application. One thing to note is this introduces a lot of opportunity for latency, because the more shards, the more database connections, the more network round trips you're making, it means that you're going to be bottlenecked by whichever server or connection is the slowest. And so long as that's the case, it just increases the probability that the query might be slower. So that might not be a problem if you're making this query just once in a while, right, where you're specifying the age. But perhaps your workload makes lots of age-based queries, right, and very few _ID-based queries. That is a suggestion there that, OK, maybe we should have, in some sense, sorted the data on age instead, so we can really make these targeted one-shard queries. And that's everything that goes into selecting a shard key, right? So this is the step where you can control how your data is partitioned across the shards so that it's intuitive for your workload. And so I thought it would be helpful both to identify some principles behind selecting a shard key, but then also go through some examples of applications, how they might pick your shard key, so that you can go home and do the same. First, what makes a good shard key? All documents having the field. While it is not a requirement that your document has this field, it greatly helps, as the routing table then can reference the document by that key and map it to a shard. High cardinality. High cardinality means that there's a lot of distinct values that the shard key can have. And what this allows for is significant granularity when determining what the partition should be across the chunks. So this allows, again, as you continue to scale, for data to be moved around seamlessly and effectively. And third is logical for your query patterns. So going back to the example earlier, if you're making a lot of queries that are important where age is important, right, it would be logical to sort your data on age, right? So it's really thinking about what your workload is and what makes sense as a logic to partition the data by. And while all those three principles are great, you're probably not going to hit them on all of your queries. So at that point, I would say really honing in on the statement, a great shard key minimizes latency for customer-critical queries. So consider which queries are most important to your customer's experience with your application, your customer perhaps adopting your application, right? Like, where do you need your process to be the fastest? And pick a shard key that enables that. Our first example is going to be pretty straightforward. It's a huge national hospital system where they keep track of all their patients as they come for visits through a document that looks something like this. So they have an _ID value, which is a sequential value, monotonically increasing value that identifies the patient. They have the name and insurance information of the patient as well, and then stuff specific to the user, to the patient. So let's go, how would we pick a shard key here? Maybe you'll consider name, but name is not overtly unique, right? Many people might have the same name. So let's eliminate that. Similarly, insurance can be eliminated because there's only a handful of people, or a handful of insurance providers, and maybe everyone wouldn't even have insurance, right? So that violates both the high cardinality principle as well as every document having this value filled. If we also consider the workload that the hospital would have, they're making a few inserts, right? Every time a new patient comes, they insert a document. They're making a lot of updates. every time a patient revisits, they're updating their document. And one patient visiting really doesn't tell us much about if another patient will visit or not. So in this case, the uniqueness of the underscore ID value will actually be very useful to us, right? Because then we can make a targeted query to the one document that is relevant for that patient. So let's pick underscore ID as the shard key. After doing that, the balancer partitions the data across the shards by that shard key. Again, this range is kind of arbitrarily picked for the sake of demo. And documents are inserted while they are inserted in a monotonically increasing fashion, right? So they'll start kind of from the left, move right. Majority of our use cases are updates, right? So since we're making tons and tons of updates, that part of the querying will be randomized. And since, I don't know, patient 2 might come today and then not come for another couple years. And so at that point, we're distributing the workload evenly across the shards. And we're not creating what is called a hot shard, which is when you make lots of reads and writes to a singular shard with our inserts. That'll all be on the last shard. But let's consider another example. Perhaps we're distributing vaccines. And this vaccination, there's a week span that everyone in the nation has to come take the vaccine. And the hospital is now inserting documents just identifying if someone came and took their vaccine, right? So it's a new collection. At this point, the workload is very heavy on inserts, but low on updates, right? Once one person takes their vaccine, they don't have to come back. It's a one-time shot. But there's a lot of people coming all at the same time, which means that if we continue to have a partitioning like this, if every patient that visits gets the next value for their patient ID, it would all go to this last shard consistently, right? Which would create what's called a hot shard. And this is disadvantageous because then you're not using that full capacity of all 4 shards, of all 4 servers. So a solution to that could be to hashing your ID value, right? And this ultimately randomizes what was otherwise a monotonically increasing value. And at that point, the inserts are still randomized across all the shards. Once it's hashed, it could go anywhere, and at that point, the data workload is distributed evenly across your shards. But that was a pretty simple case. Let's go to a more complex example with Twitter. Even here, we're going to consider a very specific subcase where we're only considering making reads in order to populate these 2 pages. Specifically, the first is your uploads page. So perhaps you're like my friend Sam here, and you have a lot of opinions you like to share with the world. Specifically, number 1, Gardettos are still so good. If you're like Sam, you check your uploads page a lot. You go and you like to see what is the user engagement on that page. You like to see, are my tweets still live or did they get removed for some reason? Or maybe you're like my other friend Tristan here, and you are you're a scroller, like most of us, right? You don't tweet too much, but you like to view the news feed. Again, in this subcase, we're going to consider that everyone views the same news feed. It's just the most recent tweets in the world. Sometimes prioritizing one of these customer critical paths will come at the cost of the other. And so what you'll have to do is evaluate how picking a shard key that prioritizes one over the other affects your customer's experience and thus can inform which field to pick as your shard key. So in order to do that, let's first pick Team Sam and prioritize populating the customer's upload page. So this is the user document for every tweet. We keep track of the handle that the Twitter user has, information about the post, and then the timestamp itself. And here, since we're prioritizing populating the uploads page, which is going to be all information regarding that one user, right? We're going to pick the handle to be the shard key. What does that do? It means now the data is partitioned across all of the shards by handle, right? And when the uploads page is populated, it is a targeted single shard query for Sam Zhang's case, this last column, right? This last shard. Whereas populating the feed will be a query that targets all of the shards, because it is like the feed will be showing tweets from people who have handles from A to Z, right? So that is a cost trade-off, right? There's a bit more latency in populating your feed there than there would be in populating your uploads page. But if we go Team Tristan, we're going to be prioritize populating your news feed. The document is the same. Handle wouldn't make sense as the shard key this time. Instead, we would pick time. And here, if we partition by time, again, arbitrary range, it means that populating the feed instead will be a single targeted query to, or a targeted query to a single shard, which would be the shard with the most recent data. Whereas populating your uploads page would be a multi-shard query. However, it is likely, unless you're Elon, you are not tweeting constantly. So perhaps you'll only target a couple of shards instead of all of them. So let's evaluate the trade-offs here, right? There's not a right or wrong answer. But if I had to say which team to take, I would go out forth and team with the side that prioritize the news feed for a couple of reasons. First, everyone uses the news feed, right? Everyone scrolls, everyone checks what other people are saying, whereas not everyone is uploading tweets, right? So already we're prioritizing more customers by prioritizing the news feed. The second reason is, imagine opening up your Twitter app and it takes a little second to load, right? You're going to close the app immediately. You're like, I'll just go to Instagram instead. And to Twitter, this is very detrimental, right? It's detrimental to the adoption of their product. So they would want to prioritize low latency for the newsfeed critical path. But like I said, I simplified this subcase a lot. There's way more complexity to it, especially given writes. We were just considering the case where you read from the database to populate your page. Now consider making writes, right? If you're tweeting, if you're liking things, documents are being updated, those are all going to be the most recent documents, right? And so sorting by time all of a sudden doesn't make sense because all of your writes are going to the same shard, and we're bottlenecked there. So as I mentioned earlier, you can do something called have a compound shard key, where the key instead would be a hyphenated version of a couple of fields, perhaps handle and time, right? Maybe even something else, right? So this is a very complicated problem, and sharding your own clusters, this is the part where you will probably want to give the most thought. However, don't be scared. We have a lot of help and support if you are struggling to figure out what to make your shard key. We have professional services, we have technical service experts, we even have booths downstairs that can all help you with this problem, with this part of sharding. However, this is another advantage to why you should still start considering your shard key and how to manage your data and how to structure it before you've reached the point of sharding, before you've reached that scale, because that can mitigate a lot of then that confusion that you hit at the end of what do I shard on if you've planned for it from day one. So the takeaways here are, first, sharding is your most cost-effective solution at scale. Once you've hit those capacity limits, shard your clusters so you can continue growing infinitesimally. Second, the architecture of a sharded cluster includes 3 components: the routers, the MongoDB, which is your shards themselves, and the config server. And together work to create this distributed database. And we here at Mongo do a lot of hard work to make sure it's efficient and it maintains the integrity of your data. And third, we have pick a shard key that minimizes latency for customer-critical queries. So there will always be trade-offs, but consider what is most important to your customer when picking your shard key. And so I hope you leave today empowered and equipped to take sharding back to your team. I see we have a lot of questions, so I'll open up the floor. Thank you.
Cool. Thanks, Sonika, for demystifying sharding for us. I will take a couple questions because we are at time. I'll just go with whoever's closest to me.
Just on the Twitter example with the compound shard key, what would that look like for a query for both the user handle page and the list page? Does it end up going to all the shards for both of those queries? Or how does that work?
So in a real subcase, right, you probably have a subsect of followers, right? So it maybe your data is partitioned on those subsect of followers plus time. It's complex. It's complicated. I think there's ways to engineer it that it doesn't, or it at least goes to a few shards instead of all of the shards. But yeah, I'm not 100% sure.
One more.
Thank you. This was a great session.
Thank you.
So same on the Twitter example, right? If I want to prioritize some of my Twitter handles, you just said you're not Elon, right? Everybody watches Elon tweeting, right? So in that case, what should we do? Because what we are trying to do is we are trying to balance out sharding by, having a shard. I want to like celebrity tweets, if I want to highlight them.
Yeah.
What should be our approach?
I mean, perhaps you could have a field that like you're inserting as a tag that it's like a verified, you have the check mark on Twitter, right? So maybe it's a verified follower or a verified person. And that could be something that you include in your shard key, right?
Adding one more dimension to our model so that you shard on that again.
Yeah. That could be a solution.
Cool. Yeah, let's do our last one.
Hi. So when selecting a shard key, should you also do it in tandem with selecting what fields to index in order to provide the best possible or reduce latency for the end user?
Yeah, definitely. So you're actually required to index the field that you shard on.
Okay.
So exactly what you said. It'll really reduce latency to do both. But just because you've indexed on a key does not mean you need to shard on it. But the vice versa is true.
Right. Okay.
Yeah.
Thank you.